All right, so we're continuing work on our Space Invaders. So this is I guess the sixth part, sixth lesson on this, and so we had it going pretty well. We had built our alien fleet, and we were observing kind of our alien fleet dancing on the screen here. And then when we actually ran this on the board, though, what was happening is it was freezing up, and the reason why is because we were experiencing stack overflow, and the reason why is because we were using up all of our RAM with our display object, which we allocate here, and then with our AlienFleet game object. And so we've had to kind of go back here, so this is an array of game objects, and so basically we have, in this example, 20 aliens, and so because there's 20 of them, then we have 20 game objects, and so we multiplied the amount of memory required for one of these game objects times 20, and that was sucking up all our memory. And so the plan here, and I guess previously we also made some move loops to handle like the movements and the rendering and the sounds. And then we started building a new class called the AlienFleet, and the goal here is to basically create a single game object and use that to render the entire alien fleet. And so we made an instance, or we made that an alien fleet class that's going to inherit from game object, which means it's going to have all these functions we built and all this data that we did. We had to change this to protected from private so that we can access that data from in here. And now what we're going to do is we're going to do our override. So we overrode the draw function here. And what we're also going to do is we're actually going to, let's start by making our move function. So we're going to let's see, move. Actually, this is what we'll do. Move fleet. Okay, so we're going to make use of the existing functions that we already have. Okay, and so we have this function here where we move the alien fleet, and we're going to take a lot of our logic here, and we're going to kind of replace this essentially. Okay. So the first thing we're going to do is we're going to take care of our movement. So let's say let me think for a second. Yeah, we're going to say move fleet horizontally, and bool, or no, what did we pass into it? It was our direction. Okay. Okay, and so what we're going to do is we're going to basically, so we can think of our alien fleet as a bunch of aliens like this, right? Nope, don't want that. And our alien fleet object is tracking the position of this one. And so every time we move, we want to move this one, but we want to check to see if we've hit the edge over here. And so what we're going to do is we're going to say bool, or we're going to say move horizontally. And so this function we've already written in our game object class. And so this exists in our alien fleet class because we're inheriting from game object. And so when we call move horizontally, it's going to run this function right here. Now it's going to do this calculation for us. We don't actually need it because we're going to do a separate calculation for the whole fleet. Okay? And so now, we move horizontally, and now we're going to calculate basically like our, so int right edge equals an int left edge equals, so left edge will be the current horizontal position, and the right edge will be the current horizontal position. So that'd be X position, right? So this is going to be X position plus, and now we need to keep track of our width and our height. So let's see, private, we'll say, well, I guess we know the width, right? So plus the width times, now we need to know the number of the aliens. So we're going to have const u int 8t num alien rows or columns, right? Actually, let's just do it up here. Instead of doing it down here, we'll just use the macro. So since we're doing those anyway, we're going to snag these from our main code right here. I'm going to take these, I'm going to put them in our AlienFleet class, and so we can reference them there. And then let's include our AlienFleet here, so we can grab those if we wanted them. Okay. So we're going to multiply this by the number of columns. Okay. And then we want to add a little bit of a gap there, like some spacing. So plus gap. Okay. And so we're going to say const int u int 8t gap will be 2. And this is the amount of space in between each alien. Okay. And let's see if this will do it. Let's see. So we got the horizontal position. Okay. And then we have the width multiplied by the number of the alien columns plus the spacing. No, we want to put this spacing right here. Like this, I think. And then we'll have to subtract away the gap for the end, I think. So then, let's see. The right edge will be, so let's say we have 10 aliens. Okay? So our current X position, let's say it's 0. And the right edge will be 0 plus the width is, let's say, 12. So it's going to be 12 plus 2. So 12 plus 2. Multiply that by the number of columns, which is 10. And then we're going to subtract away the gap once, because we have that edge, so that's minus 2. And so that would be 3 plus. So 14 times 10, 140, so this would be 138 for 10 aliens. So then if I have, okay, let me look how I did it here. Because we had done, when I set these up, I had 10 by 10. And the width was 12. Alright, something's wrong here. I'll come back to it. Okay, so after reflecting here, this is right. I made a mistake. I made a mistake here, and there's no gaps between the aliens. So what I'm going to do for mine is I'm going to reduce the number of columns to 8 for now. And then, so this will be 8 plus 2 times 10 minus 2. So that's going to be 10 times 10 is 100. 100 minus 2 is 98. We'll maybe even do a ninth one. Let's see. Sorry, that's wrong. This should be 12 still. This would be 8. So 14 times 8 is going to be, let's see, 80 plus 32 is 112. So that'd be 110 pixels. That's fine. 110, yeah, so we'll start with that, with 8, and then we'll see if we want to change it later. So all I've done here is I've changed my number of alien columns to 8, and this is because my alien width is 12. If yours was a little smaller, you could have some more aliens on your screen. So anyway, we've done that calculation. The left edge is just going to be X position. And then what we're going to do is we're going to say if, and we're going to snag some logic from here. Okay. So if the left edge is less than or equal to 0, or the right edge is greater than or equal to the screen width minus 1 minus the width, then we're going to return, I think in that case if we hit the edge, we'll return true. Yep. Else we'll return false. And so what this is going to do is it's going to calculate the whole width of the alien fleet, and if we're at that right edge, then we're going to basically say we're at the edge so it can turn around, and if we're at the left edge. So we'll try this out and see if it works, but this should work. So now we're going to also make one to move the fleet vertically. Alright, move fleet vertically. Okay. And then we're going to move vertically with our direction, and then we're going to calculate the lower edge equals the Y position plus 2 times the, we'll make this one the X gap, or the column gap, here, so we can have a row gap here. Okay, and so here we're going to say 2 times, and really this calculation is going to be basically the same. So I'm going to snag this here, I'm going to put it right here, and this is going to be the height times the row, or plus the row gap, times the number of rows minus the row gap. Okay, and so what this is going to do is this will allow us to add more rows if you want to add more rows. So if you want to add, like, say 3 rows to your alien fleet, you could do that, and then that should do it. So let's go ahead and now make this work with our code. And so the first thing we're going to do is here where we allocate our, or create our alien fleet, we're going to instead say alien fleet object, alien fleet. Okay. And then we're going to pass in all the arguments we need to pass in. So I'm going to hide these right here for now. I'm going to copy this over. So I'm going to set the starting positions of our alien fleet to be, we'll set the starting position to be 4, the starting Y position to be 10. We're going to use the alien ship graphic. 12 and 10 would be the width and the height. And then here is our display object. And I think that's all we need. Okay, we do want to set the speeds for our alien fleet. So we'll take these right here and put them right here. Alright, so we don't need this array anymore because it's not an array. So we're setting the speeds for our alien fleet. And now we have our move alien fleet function. So we're going to come down here and we're going to remove this part. So instead of all this, we need to write that move function still. Okay. So coming back to here, oh wait, we have the move functions. Okay, so we're going to move. So AlienFleet dot move fleet horizontally, and then we have our direction that we're going to pass into that. Okay, and then we're going to say at edge equals, so if we hit the edge, it's going to return true, and so if that's true, we're going to move our AlienFleet downward. So AlienFleet dot move fleet vertically, and then we're going to say our direction would be move down. Okay, and this is a lot simpler, right? And then we'll check to see if we're at the bottom as well, but we're probably not going to do anything with it right now. Okay, so now this is a much simpler function because we took care of all the logic inside of our class here. Okay, and now what we want to do is we want to come back into our AlienFleet, and we need to override that, finish our draw override. Okay, and so this is where we got to get a little bit fancy to keep track of the positions of all the aliens. And so what we're going to do is we're basically doing it here already. So we're going to snag this. Okay. We're going to grab this guy. I'll set the color. So we got so we know the height, we know the width. We're going to use the graphic, and so the key here is that the x position is going to be x times width plus row gap, and then the y position will be y times height. Oh, I did this back. So this should be row gap here, and then this should be the column gap. Okay, and I think this is all we need to render it. So I'm going to test it now, and we'll see. Okay, we forgot one thing here. Well, first of all, I'm going to actually make this a little more readable. So I'm going to put these all kind of together right here. Just so you can see these all. Okay, and then so that's our draw function. So now we need to come back here, and we need to say fix this. Okay, now we should be able to compile successfully. And let's go ahead and see if our memory usage has improved as well. Yep, so look, we were at 40% before, now we're down to 28.9%. It was something like 800 bytes, now we're down to 592. So we've saved ourselves a lot of memory there by making these changes. Uh-oh, and something's not happy, so let's figure out why we're unhappy. Lower edge. Oh, we didn't finish our move vertically function. Okay, so we're going to say if lower edge is less than or greater than screen height, return true, return false. Okay, so this will, for our move vertically function, which we didn't finish, now if we get to that lower edge, we're going to return true, otherwise we return false. And then let's see if we have some errors here. Doesn't like something here as well. Display. So it's an issue regarding the order again. XY graphic width height display. And then we have, oh, we gotta move this guy to the bottom. There we go. Okay, that's good. So we got all the warnings there taken care of. So now we're going to test this and see if it works. Okay, while testing, I caught that we did make a mistake here. So on our AlienFleet draw function, the issue is here. So it always draws them in the same place because they don't actually reference the current position. So I have to take the current position of the left alien and add this to it. And the same thing here. And so what this does is it takes that position, takes the index of the alien, so alien 0 will be here, alien 1 will be here offset by this much, and so on. Okay, and so that will draw our aliens, and also in our main function here, we in our draw, we actually don't need to call this draw function a bunch of times. We only have to call it the one time, because it's going to take care of drawing the whole fleet. Okay? And so that's done. That's good. Now we'll test it and it should all work for us. Okay, so it's compiling here, and there we have it working using now this AlienFleet function, or this AlienFleet class that we made to take care of movements. And so now that that's working, we'll go ahead and wrap this part here, and then the next part we'll go ahead and basically add in a way for our AlienFleet and probably even our GameObject class to determine whether, probably our AlienFleet specifically, to determine whether the object is visible or not. And so when you like shoot down an alien, then it will disappear instead of staying there. And so that's what we'll do next, and then we'll do the animation for shooting, the spaceship shooting, and then when that is done, we will be just about done. We'll add in our movements. And you can see this also solves our issue where they were crowded at the bottom of the screen based on our new process for animating it.